When you start CsoundQT, you will see that you're going to get a default CST on the screen. And so there are a few things that I'd like to show you just to get going with it. So the first thing I think you need to look at is to try to make sure that your configuration is correct. So you go into configuration here and you check that you have, for instance, the output set. You can be any of these options here. I will choose core audio here, but you could choose others. For the moment, there's no big difference. You're not using any input, so you have it clear here, and you're using output, the standard output, default output in your system. You could select different output devices here, but I would suggest you to set your default, which is just DAC. So that's good. You can apply that. And the next thing I want to show you is the template here. So this is whenever you create a new project, this is what the template that will show up in your screen, in your editor. So since we don't really need anything but a kind of a clean set of tags here, I can clear everything for the moment and set that as my template. And now I have a template, so when I say new, I get that. Okay, so we'll start with a very clean template to start with. So no matter what you do here, whenever you play, you're gonna get something run here. So there is no input here. So we're going to start. So you have an option, a message saying here that there's really nothing there. But so you can basically start by putting an instrument here with an output that will take in an oscillator with a certain amplitude, which will set to 0 dBFS, and a certain frequency, which is set to A4. And now I can run this, okay? And you can see it runs fine, but you have no sound. And the reason why you don't have any sound is because this instrument, while it's defined and it's fine, so you can actually run this, it's not being scheduled to run, so it's not being instantiated. For that, you need to have a schedule line, and you want to run it, say, instrument 1 for, say, a certain duration, or starting at a certain time, so immediately. Let's run it for 2 seconds. So the first argument here to schedule is the instrument that you want to play. The second is when you want to play it, and the third is your duration, how long you want to play it for. So now you get the sound. Okay, so that sound it runs for 2 seconds, and if you want to play it again, okay, so I can schedule it again. Say starting at 3 seconds for another 1 second. Okay, so we're gonna get and again. Okay, so there you go. So these 3 parameters are straightforward. You have your instrument number, the start time, and duration. Now you notice that when I played, I could only play one pitch at one amplitude. This is because I have these fixed here. Okay, so 0 dBFS is the maximum amplitude of the system. I could define it at the top here to be 1, which is going to be handy. So I say 0 dBFS is 1 here. Okay, that won't change anything in this case, but we have a setting now, which means that if I say put it 0.1 here, you can say it's softer because the maximum amplitude is 1, and I'm running at 10% of that. Okay. The next constant here is A4. So this is your tuning. This sets the tuning for the overall system and is a reference for things. So for instance, if you multiply that by 2, you're gonna get an octave. If you multiply it by 1.5, you get the fifth above it, and so on. So it's a reference that you can use in your code. But you can also put the frequency directly here. So if I want to play 500 hertz, you can just stick it in there directly. Okay. No matter what I do here, you're always going to play this fixed amplitude and frequency here. So what I can do next is introduce parameters to it. So this the parameters are counted from the first one, which is P1, P for parameter, P2 for parameter 2, which is start time, and then P3 for duration, parameter 3. And after that, you can invent your own. So for instance, I can say that P4 is going to give me my amplitude, and P5 is going to be my frequency. So I can go P4, so let's say 0.1, and P5, 500. For the next tone, I can say, so I'm going to last for 1 second, and I'm going to play it a little bit louder, okay, and at a lower frequency, 100 hertz. Okay, so when I play this, okay, so now we have a means of scheduling different parameters in there. So you can see parameter 4 and parameter 5. So the oscillator then will take an amplitude and a frequency, and parameter 4 and parameter 5 will do those things for control the oscillator for us. You can create chords by playing notes at the same time. So for instance, if you have that together, so let's say something like this. Let's see, we can have a, okay, you can add as many sounds as you like running at the same time, 180, whatever. Okay, so you have, okay, so that's good. They adapt together, so you can see the amplitudes here, kind of almost like 3 times each individual amplitude here. Not exactly, but because they don't add up fully, but you can see that the more instruments you add, the louder the amplitude gets. What you need to watch out is that your amplitudes stay below 1, okay? Because if they don't, you're going to be clipping, you're going to get distortion and nasty sounding things. So you always keep that under that. That's a really important thing to remember. So the next thing that we can do now is that you can see that we're producing the sound from the oscillator and is sticking straight out to the output. We can use a variable to hold those audio signals. So for instance, if you say an ASIG will take in the output of that oscillator, so I'm going to copy that here, do something like this, and then put the ASIG to the output. You can see it hasn't changed anything, but I'm having 2 separate lines, the signal being produced and put into a variable. Why would I want to do that? Let's say we want to process this further. So it would make sense then that we would store in the variable, and we will put into another variable, for instance, a out, and we'll put in the output of a line envelope. It's linen. So a line envelope then takes in, as a processor that can take in the input signal, so an ASIG there that comes from the oscillator, an attack time or a rise time, let's say 0.1 seconds, a total duration, which is the P3, or duration of the sound, and a decay, let's say 0.5 seconds, so half a second decay. So now, if you stick that to the output, so you can see the linen going receiving the asig and sending it to the output, you're going to get an envelope. You see? Now it's nicer. You have a shape. Now this envelope shape here can be determined by, you know, how long you want to attack. You want a short attack, will sound like this. You want a short decay. So it finishes very quickly. But it shapes the sound nicely. It doesn't start fully and doesn't finish fully. And it gives the sound quite a nice thing. Note that Linen can be used both as a signal processor, okay, but also as a signal generator. So if we use here, let's go, I'm going to generate an envelope here, and I'll move this over to there. Let's see. So now I can see the asig. Then instead of asig, I'm going to use the P4 value, which is our maximum amplitude. And then I'm going to replace the P4 by an AM, so this generates a signal, and you stick that signal here to process the amplitude of the oscillator, and then you can stick that to the output like that. Also asig to the output, sorry. So you put in the output of the oscillator goes to the output, and the input to the oscillator amplitude is this envelope here, which goes from 0 to P4, which is the maximum amplitude. So now Linen is a signal generator. No change. Produce the same results. But sometimes, depending on the way you design the instrument, you might want to use an envelope as an envelope generator, or you might want to use an envelope as an envelope processor. We'll see more of these in the course, but just give you a kind of an avant preview here from you know, the things we're going to be seeing later on. Just to give you an idea of more of the things that we can do in the future. Now let's focus here on one sound. Just so I'm just going to have one sound, okay? And I want to show you two basic operations on signals that are really really important. So let's say we have that oscillator there, but you want to have another tone in, so I'll call this asig1 and have an asig2, which would take, both would take the amplitude, the same amplitude, but next one is not going to take frequency from P5, they're going to take frequency from P6, so we're going to add another parameter here. And let's say I want to put another frequency here, so let's say 500. And now I want to hear both signals. What do? I need to mix them. So this is the basic operation of mixing, is to add them signals together. So if you add them together, you basically mix these two. And now when you hear the sound, you're hearing two oscillators. You can put a third one if you want. Or four. 4. Let's say I copy both. So I'm gonna get 3 and 4, and I'm going to say P7, P8, and asig 3 and asig 4. Okay, so now I can put a bunch of other frequencies here. So let's say this is random things that I'm picking up off the air. So not particular, you know, with a particular idea in mind, just to produce the sound. Now I'm going to reduce the amplitude slightly because I have 4 oscillators. Okay, so you can see you can create something quite interesting there. And then your envelope, you can have 4 different envelopes if you wanted. One, I'm using the same envelope to all of them, so it's all fine. But you see, the main thing that I want to show you is that, you know, if you mix them together, you basically add them together. So that's the same idea, is that when you're mixing something, you're adding signals together. The other operation that you might want to know about is scaling. So scaling is multiplying the signal by a certain constant. So let's say, or certain, what we call a gain value. which if it's above 1, it's going to amplify the signal. If it's below 1, it's going to be producing a certain change, you know, an attenuation of the signal. Let's change to a lower level. So here I'm going to use 4 different gains to emphasize certain signals more than others. So now you can see that the difference between that tone and that tone is because I have different gains. So and see if I put that, so we can get this. So the different amounts of the signals are given by these gain values here. So when you scale a signal, you multiply it by either a fixed value or by a very slowly varying signal. Okay, so you could put those gains here as so we have P8, P9. So let's say 0.01, 0.5, 0.9, 0.7, and I can map these to here. So P10, P9, sorry, P9, P10. So the 10th parameter, P11, P12. Okay, so now we have that when you run. You can see now, but I can generate. I can have other schedules. So I'm gonna do it. So like 1 second here, 1 second, 1 second. So I'm gonna change these. So now I'm going to keep the frequency the same, but I'm going to emphasize things differently. You should be able to hear the change in tone from one to the other. Okay, so let's have a look here at this result here. Okay, so I have okay, there was a problem here. So we'll see what the problem is. Oh yeah, we missed a comma here. Okay, so now you can see that different scaling will produce different sounds, of course. And so you have like a really interesting exercise here, or example, where you're playing around with the combination of tones, different frequencies. You can start changing these frequencies here as well, randomly, as I said before. So I'm not really doing anything. So let's see. Right. Okay, so that basically concludes our first video here, showing a few things that are fundamental and very basic, and how you can work with them.